All right, guys, we're going to dive into solving a decimal word problem using a linear inequality with variables on both sides. Let's go. Okay, so Philippe is going to rent a truck for one day. There are two companies he can choose from, and they have the following prices. Company A charges an initial fee of $35 and additional 70 cents for every mile driven. Company B charges an initial fee of $44 and an additional 60 cents for every mile driven. For what mileage will Company A charge less than Company B? Write your answer as an inequality using M for the number of miles driven. So basically, we've got two companies, and however many miles we're going, we're wondering at what point will Company A charge less than Company B? So let's actually start by underlining that statement right there. For what mileage will Company A charge less than Company B? So when will Company A be less than Company B? And now we're going to replace equal parts with, equal parts. All right, so let's start off with Company A. Company A charges an initial fee of $35 and an additional 70 cents for every mile driven. Okay, so their rate starts off at $35 and an additional 70 cents for every mile driven. Question, which one of these is 70 cents? Which one of these is 70 cents in decimal form? I think I just gave it away. Well, hopefully you chose the center. 70 cents is 0.7. If it makes you feel uncomfortable, you can write 0.70, so it also looks like 70 cents, but it has the same value. And that's for every mile driven, so times each mile that's driven. Now, let's switch to Company B. Company B charges an initial fee of $44 and an additional 60 cents for every mile driven. So 44, let's fix that. An additional 60 cents for every mile driven. And now we have replaced Company A with its inequality and Company B with its inequality, and we can solve. Now we're going to solve this just like any other inequality. We want the variable on one side and all the numbers on the other side. Right now we've got variables and numbers on both sides, so we've got to switch that up. So looking at this, there's a couple of different routes I can take, but I really want to try and avoid negative numbers. So I'm going to start off by subtracting 35 from both sides. Now, by doing that, I no longer have constants or numbers, so to speak, on that side. I'm left with 70 cents per mile is less than $9 plus 60 cents per mile. That being said, now I have my constants on one side, but I still have variables on both sides. So I'm going to get rid of that. And I can see when I think this through that if I subtract my 60 cents per mile from each side, it cancels out here, leaving me with 9 is greater than 0.10 miles for every mile. So in order to solve for the miles, I'm going to divide both sides by 10 cents, leaving me with my miles have to be less than 90. So Company A will be less than Company B at 90 miles. company A will be less than company B at a rate of M must be less than 90 miles. There is our final answer. Okay, we're going to try another one, and then we're going to recap everything that we went through. Okay, continuing on. Miguel is choosing between two exercise routines. In routine one, he burns 22 calories walking. He then runs at a rate that burns 15.5 calories per minute. In routine number 2, he burns 43 calories walking. He then runs at a rate of 11.3 calories per minute. For what amounts of time spent running will routine 1 burn fewer calories than routine 2? So let's see. When will routine 1 burn fewer, so that means less, calories than routine 2? So just as before, the first thing I did is define the problem that I'm solving. When is routine 1 less than routine 2? Well, now we need to put our stand-in for the inequality that represents routine 1. So let's start there. Routine 1, he burns 22 calories walking. He then runs at a rate that burns 15 calories per minute. So then 15.5, calories for each minute. So times the amount of minutes. Now when we get to routine 2, he burns 43 calories walking. And then he runs at a rate of 11.3 calories per minute. So, and then 11.3 calories per minute. And we want to know, when is routine 1 less than routine 2? Solve this. Again, I avoid negative numbers at all costs, whenever possible at least. So we're going to start off by eliminating our constants on both sides, these numbers here. I can subtract 43 from both sides, but then I'm going to get a negative number over here. I don't want that. So I subtract 22 from both sides. Oop, that's not 11. All right, so we've got 15.5 for each mile is less than 21 plus 11.3. Well, really, we're talking about calories for each mile. All right, so the good thing is I no longer have numbers over here. I just have my number over here. Now I gotta get my variables to the same side. So we're gonna subtract 11.3 from both sides, 11.3 m, right? 11.3 for each. Oops, that's not subtraction. I mean, it is supposed to be subtraction. Let's fix that. Which cancels that out. We have 21 is less than 4.2 calories per mile is less than 21. There we go. So now to find out how much for each 1 mile, we're going to divide both sides by 4.2. And hopefully at some point you realize that the answer here is going to be M is less than 5. 21 divided by 4.2 is 5. But if I submit this answer as is into ALEKS without being thorough, it's going to tell me I'm incorrect. Why do you think it's going to tell me that this answer is incorrect? Why? Take a second and think about that. So thankfully, I reviewed the problem. And the reason why I read over the problem before I said that's my final answer is because it actually says solve your inequality for t. All right. So I'm supposed to be using t for time. So I'm using the wrong letter variable that it wants. Now, mathematically, I'm 100%. But we also do have to learn how to do assessments in a computerized world. And that means doing what the computer tells you to do. So the correct answer here is going to be t is less than 5. I have to use the variable t instead of m because that's what it told me to do. But the math is 100% understanding. All right, I hope you guys are ready to try some. All right, last walkthrough. A phone company offers 2 monthly charge plans. In plan A, there is no monthly fee, but the customer pays 7 cents per minute of the use. In plan B, the customer pays a monthly fee of $10 and then an additional 5 cents per minute of use. For what amounts of monthly phone use will plan A cost more than plan B? Use M for the number of minutes of phone use in a month and solve your inequality for M. Okay, one of the first questions I have here is if we're going to be writing this out as an inequality, we need to know how to represent those values in number format. So let's just jump right in. We want to know what amounts of monthly use will plan A cost more than plan B. So when will plan A cost more or be greater than plan B? Well, plan A, let's see here. Where is plan A? There is no monthly fee, but the customer pays 7 cents per minute. So how do I represent 7 cents per minute? Is that 7 times M? Is that 70 times M? Is that 0.7 times M? Or is that 0.07 times M? Which one of those represents 7 cents per minute? Well, I hope you selected the last one. That is 7 cents right there per minute. So that's plan A would be 0.07 cents times the amount of minutes on the phone. And for plan B, the customer pays a monthly fee of $10 and then an additional 5 cents per minute of use. So each month it is going to be $10 plus an additional 5 cents per minute of use. And we want to know, when is plan A greater than plan B? Well, the bright side is I only have a constant number by itself on one side, so I just need to get my variables on one side. So I'm going to start by subtracting 5 cents per minute from both sides. Okay, and now I can, oh, I forgot my minute. There we go. And now we can divide both sides by 2 cents to eliminate that variable, telling us that the amount of minutes that you talk must be greater than $500, than 500 minutes for plan A to cost more than plan B. So basically, if you talk less than 500 minutes a month, stick to plan B. And in review, when we read the problem over, yes, we use the correct variable. Minutes are greater than 500 is the final answer. Now it's your turn. Just to get you set up, Salma is going to rent a truck for one day. There are two companies she can choose from, and they have the following prices. Company A has no initial fee but charges 90 cents for every mile driven. Company B charges an initial fee of $65 and an additional 80 cents for every mile driven. For what mileage will Company A charge more than Company B? Okay, so you are solving for when does Company A charge more than Company B? You can pause the video here and solve. And there is the final solution. The miles must be greater than 650 for Company A to cost more than Company B. Did you get that right or wrong? And what mistake did you make if you got it wrong? Okay, next up. A phone company offers two monthly charge plans. In Plan A, the customer pays a monthly fee of $20 and then an additional 8 cents per minute of use. In Plan B, the customer pays a monthly fee of $30.80 and then an additional 5 cents per minute of use. For what amounts of monthly phone use will Plan A cost less than Plan B? Use M for the number of minutes of phone use and solve your inequality for M. So we are solving for Plan A costs less than Plan B. Go ahead and solve. And there is our final solution. The amount of minutes must be less than 360 minutes in order for Plan A to cost less than Plan B. Did you get that right? Did you get it wrong? If you did, what mistake did you make?